what we are looking at is the life sustainability of refuge bays in underground collieries. Now, this project really, as Avurengi has said, stems from a concern that was raised during recent years where things went wrong in the underground environment. And then people relied on getting to a refuge bay to sustain their life. And some people didn't even make it to the refuge bay or out of the refuge bay. So in terms of the research then that was done, or not necessarily research, but the investigation, is the project overview. I'll cover it in more detail just now. Then we had a phase 1 to test the hardware that collieries have to ensure life sustainability, and that was tested at New Denmark. Then phase 1 conclusions. Phase 2 was the human exposure and the needs. So we can always think about, do we have enough power? Do we have enough of this and that and next for the refuge bay? But what about the individual and the emotional experience that that individual is encountering? Then life-sustaining requirements and how we can improve on that, most critical tools, findings and challenges and solutions, and then, of course, the conclusion. So, following various incidents in refuge bays where used and trauma and confusion encountered during these situations, SACMA requested Coaltech to fund research into the life sustainability of South African collieries, basically to support the managers in office, because at the end, when things go wrong, the poor manager must also stand up and say, listen, we had this in place, we had that in place, but this failed, that failed, and we feel that managers are at risk. So to ensure that the manager in office can sleep peaceful at night, what needs to be put in place? How can we support the management structure and the entity as a whole of a coal mine to make sure that people stay alive when things go wrong underground? So in 2023, we concluded the first phase of this investigation, and then, of course, this year in June, we concluded this project up to this point. The question is it really necessary? What is the reality in our underground environment? And this is typically a graph that was sourced from the DMRE records to say that in 2 consecutive years, from January to June, we had over 120 fires in the mining industry. Now, that is an awful lot of incidents where people could have lost multiple lives. And that is why we have to be ready. When things go wrong in the workplace, you cannot afford to have it going wrong on your route out of the mine. Because when you get there, what do? You're facing death. And the only thing that you have to rely on is a single nylon lifeline with a few bobbins on, hopefully to take you to a place of safety where you can survive this traumatic incident. The question is, at this point in time, guys, when you get there, do you turn around and walk away? Do you go back where you come from? Or do you grab the line, bite the bullet, put on your rescue pack and go through, hoping that you'll end up in a refuge bay? Provided this lifeline isn't broken somewhere else into the next few splits before you get to the refuge bay. If that is the case, I'm afraid we have got big trouble. So to enable us to make sure that people can reach the refuge bay and then stay there alive until rescued, that is why we undertook this project to say, but if they get there, then what do we need to have in place to make sure people can stay there until the rescue team can remove them from the mine? So task 3 here was really the essence, the practical test last year, to say that what equipment and hardware do we have to utilize our borehole system to keep people alive underground. And New Denmark was then host to that part of the project, and we thank them for that initiative. What we basically tested was fans and ancillary equipment. So on the left-hand side, you see a typical installation underground at the bottom of a borehole casing into the refuge bay. Battery-operated fan, battery is constantly linked onto the mine's power supply with some cable. And then when in need, you can switch on that fan and it will draw ventilation down the mine, down the borehole, into the refuge bay to sustain life and at least provide oxygen, pressurize the refuge bay and make sure that fumes from smoke cannot enter that living space. On the right-hand side, fan number 2 was a Sasol diesel-driven trailer-mounted device. And then New Denmark's own facility from that trailer, which is equipped with generator, fan, lighting, and ancillary equipment. Those are typically the things that were tested during 2023 in May month. And short findings, there's a long report covering all of that, but in short, the positive pressure was achieved by all 3 devices. Fan number 1, the underground installation, only gave 10 Pascal. Fan number 2 is 110, and fan number 3 delivered 20 Pascal. Now, is that good enough? Yes. Pressure, any pressure higher than 2 to 3 Pascal is good enough in a refuge bay to keep smoke out of that living space. The question is, only having pressure is not necessarily the end of it all, because we have to provide sufficient oxygen to the people inside. So I just took a small calculation from some study that was done previously, and it says that 22 people in a confined space will need at least 5,600 liters per minute, or 0.094 cubic meters per second, to stay alive with sufficient oxygen, and we call that air changes. So this recommendation about 3.5 air changes per hour would meet a comfortable living condition. Now all 3 fans achieved that. With fan number 1, not really 3.5 air changes. So well, one can expect a little bit of discomfort at some point when 22 people is hosted in a single refuge bay. Nevertheless, any comments?
No, continue. It's individuals
okay,
joining,
nevertheless,
but carry on.
Okay, thank you. I also include the criteria that was used to assess these devices at the time, just for interest. And I know it's a busy slide, but some people might take an interest in the conditions and all the parameters that were considered to get to this answer. So fan number 1 gave us 2 air changes, fan number 2 gave us 13 air changes, and fan number 3, 5 air changes per hour. Then a summary of the findings from the phase 1 test is 150 millimeter borehole. As the only facility for providing food, water, and ventilation, will most probably fail dismally as a life-sustaining avenue for the number of people accommodated inside the refuge bay. The borehole that was used at New Denmark was 203 millimeters in diameter. It's typically an 8-inch borehole. And we saw that that is just enough space to have a low resistance, low enough, so that the small fan underneath the casing inside the refuge bay could still perform. If there was, and the extensive report covers it all, about the system resistance of boreholes, and then we saw that fan number 1 could not make it because there's 4 times more energy required if the borehole size drops down to 150 millimeters. So the proto team members that were present during the New Denmark test confirmed that they could not effectively use a 150 millimeter borehole to provide life-sustaining supplies to the refuge bay occupants during a recent fire, which was prior to May 2023. Because of the limitation of space and then, of course, the system resistance of that particular borehole. The picture there is typically a supply cartridge showing 130 millimeter in diameter cartridge from New Denmark's equipment. And you can imagine if there is the slightest kink in or strata movement in your borehole, then a 130 millimeter device will most probably not go through a 150 millimeter borehole. So the conclusions from phase 1 then was just having a refuge base not enough. Ensure that what you have will be life-sustaining in all aspects. And that's why phase 2 was then considered, and the conclusions from that will put more light onto this. So 150 millimeter boreholes may get you into trouble instead of being life-sustaining, because you depend on that particular facility, and then when in need, it might fail and you cannot get food or water through to the incumbents of the refuge bay. Number 3 there is conduct regular borehole testing to ensure that data movement does not impair borehole integrity. We've seen a number of boreholes in recent times. Strata movement does happen. And when you put your camera, for example, down that borehole, you can immediately say that this borehole is null and void. You think on surface there is a casing protruding, and you anticipate that that casing will be the same diameter through the strata into the mine. That is not necessarily the case. So run your battery fans to measure their runtime and air quantity with the main fans in off position, typically on maintenance of main fans, and are your refuge base equipped with a ventilation outlet to expel stale air. That's important because where do you go with accumulated carbon dioxide in the atmosphere? You have to have some facility to expel, like a pipe going through the wall into the mine to expel stale air. Now, phase 2 then kicked off as an emergency escape drill was performed, where the life sustainability process inside an underground refuge bay was monitored with real occupants. We had 12 volunteers that stayed there for a 32-hour period to determine the morale, real life reactions, and the conduct of survivors during an emergency. Kangra was the host for this, and we thank Peter de Pre for his courtesy of volunteering his mind for this exercise. Now, human needs are mostly not understood. We think you provide a refuge bay, you put some benches, you put some ancillary equipment inside there, and you're good to go. You've got a long checklist, and every month somebody goes through and check, and everything is there. Signs and signals, telephone is working, and all of that. But guys, picture 1 year was taken about 2 to 3 hours after we entered the refuge bay, 2 o'clock at night. And then you could see these people had been awake for about 20 hours already, starting the morning, typically going to work to the mine, going underground, start cutting, start loading, busy with the day task. And then suddenly there's an alarm. Now you may have to evacuate, maybe 2, 3 o'clock in the afternoon, just before shift change. And now you are in trouble because you have to evacuate. And what follows next? So by the time that this picture was taken, these guys were awake for 20 hours. And you can see that. They couldn't stay upright. They couldn't support themselves. Fortunately, the ventilation curtain was available in the refuge bay. And that is normally not part of the equipment that we foresee. However, you can see picture number 2. What use was that ventilation curtain? So caring for survivors in distress is absolutely important. And the basic needs is space, comfort, heat, uncertainty, anxiety, fatigue, toilet facilities, and then mixed emotions. One of the most important things and mostly overlooked. Now, how do we keep people alive? We, in previous rescue operations, one would say, oh, you get some food from the local roadhouse or Kentucky Fried Chicken outlet, which is open 24 hours. If this happens 2, 3 o'clock at night, 4 o'clock in the morning, where do you find food to keep these people alive and just support them in their dire strait? So what we found in previous incidents is that solid food didn't help much. And then I sourced a nutritional package from a nutrition. And this is typically a recommended package of products that will provide nutrition but reduce the need for warm or edible solid food. And there's spin-offs that I will discuss just now, but the benefits of nutritional products versus solid foods was really one of the success measures of this project. Now, these are things that you can keep in a locker in your office or in somebody's special storage facility because they have a very good shelf life. Some of these products have 12 to 18 months shelf life. And it's important to make sure that when you reach the end of the shelf life, just exchange the stock. Issue this. This is really not an expense. This comes at a very, very low cost. But issue it out to people, replenish your stock frequently, and then you know you've always got the stock available on your mind whenever it is required. So the most critical tools in this case, of course, is that supply cartridge. It could be a different length, it could be a different size, but in this case it was 130 millimeter diameter. It was 1.37 meters long, and it is a steel structure. You would put the proviant inside this cartridge and close the lid with a screw cap at the bottom. Then the tripod, very important, because how do you raise this? This thing is quite heavy when you have to handle it by hand. But the tripod is important. You've got the fan connection onto the casing, and in right behind the bottle, you can see the fan standing on the grass there. This is in the middle, typically an emergency trailer with a generator and a winch, light mast, and other tools and equipment like grass cutters and spades and many other things that might be required in an outdoor facility like this. We also had fuel supply cans available and fire extinguishers, so the whole thing was complete. On the right-hand side was one of the most important devices with a facility of connecting a cell phone to a camera system that was pre-installed in this case underground in the refuge bay, so that we could have visual contact of what is happening inside the refuge bay. And the value of this visual picture will be explained just now. So what we found was the temperature underground stayed fairly constant at around 17 degrees during both day and night. Humidity rose to 72% because the fan from surface was not operating for the first 7 hours to test the air quality deterioration. Now we saw that carbon dioxide in the 7 hours rose from 0.02% to 0.26%. And when the fan was started, cold air was blown down the bottle, and the team immediately welcomed the cool, fresh air. However, humidity stayed high because there was a borehole or water seepage around the borehole into the refuge bay. That is the first thing that provided moisture, and the second thing is, of course, we expel moisture from our bodies, and that kept on raising the humidity level up to that point. Now, when we start with that kind of humidity level, there's no evaporation to dry out your clothing, so clothing starts to become damp on the body skin, and then you start getting cold even at 17 degrees. Lighting, we found that 3 fluorescent lights were kept on, ensuring optimal observation and camera image. So this became a nuisance when the volunteers tried to sleep. However, we had to keep them on, and they appreciated the fact that we needed the surveillance. But in real life, there must be some mechanism for the incumbents of the refuge bay to switch off that light and maybe just keep 1 or 2 cap lamps shining for ease of moving around. Conversation noise was noted during the first few hours. Now we've got all these 32 hours on video. So video snippets are available, and we can package that in a training program at some point to show people what is happening and how it is impacting the guys next door, next to these people. Nevertheless, the conversation noise was then followed by singing because people started becoming bored and they started to deflate their emotions with the singing, but then other people wanted to sleep because they have been awake for so long, and that started to develop into conflict. Boredom kicked in very early. This was one of the main frustrations of team members. Sit around doing nothing, waiting for something to happen, and nothing really happens. So that resulted in a mixture of emotions throughout the experiment. However, how some people started to overcome that is to just get up and walk up and about. Between the two sides where you saw the sleeping bodies, there was free space, and people utilized those few meters just to walk briskly to and fro, just to get some blood circulated and to pass the time. Space allocation, we often work with a space allocation of 0.6 square meters per person. That is contained in literature from many years ago. But in this case, you could see from that picture that we started off with, there's no way that 0.6 square meter per person could suffice, because the bodies need space. You need room to sag your body, to relax, to lie down. You cannot sit upright for 32 hours in one position with 0.6 square meter per person. It is impossible. Sleeping arrangements, standing and sitting in an upright position for extended periods gets extremely intolerable, and at some point fatigue just sets in and the people just want to sleep. Keeping warm, you see the picture with the space blankets. The space blankets were highly appreciated for keeping warm and added significant value. They should be stocked on the mine and included in a capsule supply. Now, those 12 blankets that we provided was about 20 millimeters in length. They are packaged in very small plastic bags, and you just put the whole 12 units in that supply capsule. It doesn't take up space, but the value to the incumbents underground is really much appreciated. Waste management. There was no waste management facility in this refuge bay, and we also didn't think about providing just a refuge bag to the guys. So eventually the nutritional containers, the sackies and things were just thrown away everywhere, and the place started to look untidy and dirty. And that also started to bring anxiety into the people. They didn't feel comfortable because of looking into all these waste pieces lying around. The first aid storage container, you saw that perhaps at the start of the presentation, close to the entrance of the refuge bay. And the problem with that is the area becomes crowded because as many people move into the door of the refuge bay, they start milling around, and some open this lid and want to take out whatever is inside the first aid container, and other people can't get through the door because it is now being blocked. So keep that facilities, keep it away from the door so that people can walk freely into the refuge bay, open this door, close that door, and utilize the airlock, because we also saw that people don't utilize the airlock. They open the first door, they open the second door, and in they go. 12 people in a row. Nobody utilized the airlock facility. Now, if there was to be smoke in this exercise, obviously there's no fan yet providing a positive pressure, because the first guys going into the refuge bay must then activate that fan. Now, if both doors are open, the borehole was upcasting, you can imagine the plume of smoke that would have entered that refuge bay. Guys, we have to utilize the facility of the airlock system with our double doors. Otherwise, you're at risk. So, personal hygiene, we didn't provide soap or sanitizer. We didn't think about that. Nevertheless, these come from the feedback that we had with the people afterwards during the debriefing session. So personal hygiene could not be applied after people went to the toilets. There was no sanitation facility for females. We didn't even have a female on the surface support team to talk to these guys, because we just didn't consider that. And now afterwards, we think, well, there's more to it than meets the eye. So these should be provided with a capsule upon request. Providing food, just getting back to the reality of solid food. From a previous experience, people said to me during that debriefing, don't give us Yogi Sip and Kentucky Fried Chicken, because it is dry and cold when we eventually get it, and it makes us thirstier, and our water was finished. You know what happened, guys? 14 people entered into a refuge bay. They walked through that smoke that I showed you the picture with a lifeline. The debriefing team said to me, they were so traumatized and scared that on way in the smoke, on way to the refuge bay, people just started to give up. They would just drop down to the ground and let go of the lifeline. Then the guys just behind them would pick them up. You can't talk because you've got your rescue pack in your mouth. And they would just feel this body lying on the ground, pick them up and shove them in the direction of the refuge bay. That is what is reality, guys. So by the time that they got into the refuge bay, everybody's eyes were burning. They were thirsty like second to none. And a single 25-liter container of water didn't go far. To wash them, just rinse their eyes, wash their faces, and take gulps of water. So by the time that the food arrived, the water was done, finished. Food allergies. The volunteers in this case had an opportunity to list their food preferences or allergies. Surprisingly, some listed pork, some listed beef or tinned food, and fish as types of food to avoid. Now, during an emergency, one would normally just have an umbrella supply. You buy hamburgers and whatever. So whoever must eat the stuff must carry the consequences afterwards. And now we have an opportunity to consider this. When people enter a refuge bay, consider asking them, are anybody allergic to any of these things, so that we can provide something different. The benefit of it all is the nutritional package that we provided. Eliminate this risk completely, because you don't fall into this trap of supplying these different products. Stay with the nutritional products. It makes life so much easier. So during the debriefing, people said the nutritional products was good, and they did not get hungry and stayed energized throughout the 32 hours on the ground. It was not needed to toilet so often as would have been with solid food. The mood and morale had a significant positive change every time that they received cold drinks like Coke and a candy bar. Toilet facilities must have lids to prevent exposing all chemicals and excrement to view. You don't want to get to the toilet and look at all sorts of things, but the fumes from these chemicals are noticeable in the refuge bay due to the open lid design. So fresh air freshener should also be provided to mitigate this issue. In the summary of phase 2's findings, supply capsule and boral casing. The supply capsule in this case was 1370 millimeter long, and the casing stood 1.5 meters above the concrete plinth. So that was too high for the tripod. The tripod and the casing with a fan connector on top of that. You see the little green bracket in the picture of the left. That was too short. So by the time that the supply cartridge reached the top of the tripod, it had to be lifted out with hands by 2 or 3 people. And that poses another risk of hand injuries. So rather keep casings shorter and ensure that your tripod that you use match the difference of your supply cartridge. Then on the right-hand side, the tripod needs plinth support. Now this concrete facility was too small, and that resulted in the tripod standing on the concrete here and there and other places on the soil. So that resulted in the tripod running off-center. When the winch was lowered up and down, somebody had to hold the cable with a device, not with the hand, but with some device, and that caused friction. Although the cable was provided with a sleeve, the friction started to erode the sleeve, and then the cable started to be compromised. So provide a plinth that is large enough to accommodate the outer perimeters of your tripod. Then just surface support facilities, the location, access to and condition of refuge bay borals. So from a previous fire, I was told that when a cell phone location pin was provided to the proto captain, which was from another mine, after dark ended up nowhere because they couldn't find the boral. So the consideration is to use the WhatsApp application, What 3 Words, download that onto a number of cell phones on the mine, and then drive the routes and pin your location for every boral. And that will make life easier for people having to drive after dark. Even security can use that, because we know that borals are a bit of a contentious issue as far as cable theft is concerned. But make sure you plot your refuge bay borals and the access routes. Now, ensure that the mine staff, such as surveyors, ventilation and services staff and security personnel, also know all routes to the refuge bay borals, because what happens when, during the case of emergency, we had 11 o'clock, 12 o'clock at night, the surveyor was not available, the ventilation guy was new on the shaft, the services guy has never been around to these borals, and the security guys were rotated. So nobody knew exactly where these borals were. They didn't know what farm gates to use. And that was chaos in the middle of the night. Ensure farm gates access with proper key control systems, because it must be the tags must be completed with names, numbers, and spare keys listed. And then ensure that the brims of the boral casing, both on surface and underground, is smoothed by removing grinder residue to prevent hand injuries and damage to the winch cable. In this case, we fortunately had a baby grinder available, and we could clean out the shavings on the top of the casing. If we didn't have that, the winch cable would have been at risk of being severed, and also then hand injuries by handling that heavy supply cartridge in and out the boral. Then, being a farm 2-track road with turnoffs, visitors from other mines can miss the correct road. That's why the What 3 Words is so important. Gates, protruding, rocks and dongas, those pose a real threat to reaching your destination, especially during dark times. You don't know what's lying up front in the road. And during the raining season, dongas can easily develop, and then one don't know about that. So if you don't inspect your access roads frequently, you will get to a donga, and that is basically the end of your rescue operation within the time limit that you have. Then ensure that the top of the borals remain open to vent any possible gas, moisture, and stale air accumulation. Close them with a grit mesh. When we removed this lid from that boral, we could easily have had a fatality, because that first plume of stale air rising from the refuge bay was so intensely filled with carbon dioxide and moisture that one whiff of that could have resulted in somebody fainting right next to that boral. Fortunately, there was a strong wind blowing, and the guys removing the lid didn't stand right over the boral casing. Then the second thing is emergency trailer availability and logistical support. Relying on other mining teams and their emergency trailers is a failure, because mobilize their personnel and dispatch their own emergency trailers to the mine in need. Trailers are not always licensed for public road use and may require transportation on a flatbed truck equipped with high-up loading crane. In this case, borrowing a trailer from another mine may cost everyone dearly, because it took a full day, 10.5 hours to transport from the New Denmark trailer to Kangra site during normal working hours. The truck left Kangra the morning. New Denmark is about 170 kilometers from there. By the time the driver arrived at the gate, the security must find somebody that knows about the collection, because not everybody knows about that. And then a gate pass must be completed. You search for the book, who must sign it, who's got authorization, who does the inspection of the device before it is loaded. And all these things take a lot of time. So then, very important, the receiving mine must immediately provide generator fuel, as the tank may be close to empty when that generator arrives on the receiving mine. And you may provide diesel, and in the meantime it's a petrol generator. So you must know, when you borrow a trailer from a supporting mine, what is the fuel usage of that facility? Then support teams in need, guys. The entire life-sustaining task relies on the surface support team, because if these guys are not staffed fully, I mean, we were awake the 32 hours around the clock, even more, because we started off the day like everybody else, and nobody really went to sleep because of the 24-hour monitoring. The right-hand picture, you see the screens that had to be monitored for gas, and the camera had also a voiceover, so we could communicate directly with the guys, not being dependent on a telephone line. However, the cables from these devices also had to go through the borehole into the refuge bay. And that is why the cable alone was about 20 millimeters in diameter for the power supply, for the monitoring equipment, the camera, and the sling supporting these devices. So you need to have space around your supply cartridge into your borehole casing. Otherwise, you remain at risk of losing it all. Then on surface on the left-hand side, unpleasant circumstances, at 3 degrees and wind speed of at least 6 meters per second at some stage was measured. Now, this exercise was done in the winter so that we could see what is the total effect of these circumstances, both on surface as well as underground. Now, at least the 3 degrees didn't develop underground. However, for these few guys on surface, it became a real challenge. Then in conclusion, from the manager in office, uncertainty, fear, and stress. Now, I'm not going to read all of these things to you. The question is really, as a manager in office, the slides will be available, guys. Please take time to study them again. The final report will get published now, I think next week. It's a lengthy report, but study the detail of that. I cannot cover all the detail in such a short presentation. However, it's important that we ensure that everybody participating in the rescue operation, preparation, conducting, and the aftermath, cleaning up, debriefing, adding value to the system before a next incident happens in the industry. We need to share these things. These learnings are critical. So Peter de Pre pinned a few learning points to us, and I think it is important that we take this to heart, because in a real life scenario, it becomes very unpleasant very soon. So Peter just said there, fortunately his exercise was stress-free, but I'm acutely aware of any opposite scenario, and my commitment is to zero harm. You must remember, by the time that we need the emergency procedure, safety precautions and controls has failed elsewhere in the mine. That's why we cannot afford it to fail during emergency and evacuation processes. Making every second count. I mentioned the first 7 hours, and in my report it is covered in detail. Why 7 hours? Because I needed to see how long can people survive in a refuge bay before they start getting short of oxygen. And the oxygen level dropped with 0.25%, 0.26% was the result after 7 hours. And the CO2 had risen. So that combination of less oxygen and increasing of CO2, it's a double whammy. People started to become short breath and anxious because unconsciously they didn't realize that the oxygen was becoming depleted and the CO2 was rising. So it's important. 7 hours in this case was only 12 people. If I had 24 people in there, it would have been 2 to 3 hours. And then you have to have your trailer and your surface equipment in place. You cannot depend on somebody else that might have a trailer, that doesn't have a flat wheel, whose generator is not working, who hasn't got the operator available. I mean, back to that cell phone. I was operating the winch and I could immediately on a cell phone see that winch, as the supply cartridge cleared the casing underground, I could see the people handling it out. I slacked the winch slowly, so that they could remove the cartridge safely. If I didn't have that visual, the supply cartridge would have plomped down and maybe injure somebody waiting for it underneath the casing. When we returned that cartridge, it got hooked onto the casing the very first trip up. And I could see that on the cell phone and immediately stopped the winch. If I didn't have that visual, the cable would have snapped, the supply cartridge dropped down, the cable snapped out of the bore, maybe injuring somebody on surface, and then we are losing time because now somebody must splice again underground. So that you cannot go without your own trailer. You cannot go without a camera that you lower down. The first thing that you must do in emergency, get your camera in the refuge bay. It's got sound, it's got visual, and you can talk to the people and see what you are doing. You have to connect that to your cell phone so that everybody is connected and you can freely rescue the people. So that is in very, very fast speed, very contentious issue. Are there any questions?
Great. Thank you, Inus, for that. I must confess, this is one of my favorite Coaltech projects because it's so practical. It's one of those projects where you're able to walk away and today or even tomorrow implement some of these findings and insights. We do have time, and thank you for keeping time, Inus. We've got time to take a few questions, and hopefully there'll be a few more. The report, as Inus mentioned, will be on coaltech.co.za next week. The slides will be distributed, but this talk will also be available on Coaltech's YouTube channel. With that, Brittany, Dimpo, you can go ahead and hopefully you can take a few more questions as well.
Yeah, thanks, Abraham. It's Festus. I'm sitting with Dimpo. That's the ready.
Perfect.
Okay. Yeah, thanks to Inus for the comprehensive presentation. From my side, it's not a question. I think it's just a comment looking at the challenges that Inus raised around the delivery capsule. Like, I mean, I think the weight is a concern. And then he also mentioned the size. I think on the weight, maybe as part of the recommendations, we can look at maybe using lighter materials for the design of the delivery capsule. I mean, even if maybe it's fiber or I don't know, but lighter material for the design of it. Thanks, Abraham.
Thanks, Festus. Inus, just checking if you want to comment on that.
I agree, but the reason why, and I think you can check with the proto team there, I think they've had lighter material cartridges before, but probably didn't last. The things tend to break, and then you sit back with square one. So it is a consideration to have a lighter material device, but just be careful that it doesn't get strained or crushed in this process.
Thank you. Just checking if there are other questions or even comments from the team. Again, it's one project that we're really hoping it will reach out to not only the coal mining sector as a whole, but the mining industry in general. Because if you can save a life because of the insights that come from this work, I think would have added value as an association. But happy to take any other comments before we adjourn the session. All right, with that, Inus, I can only, on behalf of all of us, thank you for the effort that has gone into this work, all the days and nights that you spent putting together the report. Thank you for that dedication. Thank you for the time. We will make the report available as mentioned. With that, thank you everyone for joining. It is hot, so here's to hoping for a bit of rain. Till next month when we will have the next masterclass. Take care. Thank you for your time. Cheers.
Thank you, Chair.